this is exactly where we started with A2 Equilibria कि उसमें मैंने explain किया था कि Kc जो product concentration over reactant concentration उसकी ना different applications होंगी. One of them is a water constant, which is that water molecules they whenever you have water, every solution is kind of made up of water. ठीक है, water is everywhere. तो उसके अंदर मैंने explain किया था कि when you have water, water ionizes. It produces two ions. One is OH minus one is H plus one, the other one is OH minus one. तो उसके अंदर मैंने explain किया था कि you had this H plus one actually is never formed. We write H plus one conventionally. We do write H plus one. But body के अंदर ना there is no H plus one. It's what happens is that the H plus one natively gets bonded to water molecules and it actually forms H3O plus one. तो जो actual चीज आपके पास है ना that's H3O plus one. But anyways, let's go with this equation. Water ionizes और इसका जो Kc होता है ना equilibrium constant, that is H plus one concentration into OH minus one concentration divided by the water concentration. तो ये जो चीज होती है ये constant होती है. Or water is in excess, so whenever water is in excess, so you don't write it in the expression. So us Kc को ना you call it Kw. Kw is H plus one concentration multiplied by OH minus one concentration, and this product is always a constant. Pure water में ना H plus one is 1 times 10 power minus 7 mole per dm cube and OH minus 1 is 1 times 10 power minus 7 mole per dm cube. तो जो Kw है ना इस एक्सप्रेशन का जो Kc है, this expression product over reactants, ठीक है, this Kw is it has a value of 1 times 10 power minus 14 or it's a constant just like Kc. Remember this is Kc, actually it's known as a water constant. What happens is it's always 1 times 10 power minus 14 और इसकी value fixed होती है. It only changes with temperature. If you change temperature the value changes. और फिर उसमें कि your solution, your water could become acidic, तो H plus one ज़्यादा हो सकते हैं. The OH ions could decrease, but the product will always come out to be 1 times 10 power minus 14. If it turns basic, then the H plus one ion concentration will decrease and the OH ion concentration will increase, but the product will still come out to be 1 times 10 power minus 14. So Kw is H plus one concentration multiplied by OH minus one concentration, and it's always 1 times 10 power minus 14. और इसका अपना एक alternate expression होता है, which is that you take the negative log of both sides. So the same expression, you take the negative log of both sides. Negative log of 1 times 10 power minus 14 is actually 14, and the negative log of H plus 1 into OH minus 1, that actually comes out to be negative log of H plus 1 minus negative log of OH minus 1, that's equal to 14. ये जो negative log होता है ना concentration का, that's actually known as pH, and the negative log of OH minus 1, that is known as pOH. So this is actually pH plus pOH is equal to 14. अच्छा, लेकिन मैं उस पे move कर जाता हूँ recent चीज जो I'll send you video lectures on this, ठीक है, बल्कि class के end में we can also discuss. The important thing that we were discussing recently was that I was explaining that there are some acids which are weak acids. There are a lot of acids which are weak acids. So you've got ethanoic acid, that's a weak acid. Ethanoic acid will ionize and it will produce ethanoate ions and it will release H plus one ions. But the concentration of H plus one ions will be a lot less than the concentration of the acid because it's not going to ionize, or it's going to ionize very weakly. कि अगर 100 particles होंगे ना, only one of them will break down to produce H plus one ions. You've got a number of weak acids. So every acid, it ionizes and produces H plus one ions. So the general equation for a weak acid could be written as this, that there's an HX, it releases H plus one and produces some random negative ion. So since it's an equilibrium reaction, it will have a Kc, and that Kc is known as a dissociation constant K for the weak acid. So it's product concentration divided by reactant concentration. It's H plus one concentration into X minus one concentration divided by HX concentration. So every weak acid will have a value of K. It will have a separate value of K. And it's going to be and it's going to have this expression. Just for example, अगर आप propanoic acid का करोगे, तो it's going to produce H+1 and it's going to produce propanoate ions. So the K expression will be H+1 into propanoate ions divided by propanoic acid concentration.
Sir?
हाँ.
सर इसके अंदर के ए लिखा, इससे पहले के डब्ल्यू था, ये एक्सप्रेशंस किसी तो समझ आ रहा है कि कॉन्सेंट्रेशन है ना, और ये बाकी का नहीं पता के और के डब्ल्यू.
नहीं, ये केसी ही है. it's just an application of केसी. मतलब मुझे तो इसमें केसी यही है ना कि this is known as the acid constant or acid dissociation constant. कि when you apply Kc to a weak acid, कि weak acid ionize कर रहा है, it's producing two ions, right? And this is the general equation for the weak acid, that it will produce an H+1 and it will produce some negative ion. Just like यहाँ पे the negative ion is ethanoate ions, right? So the Kc of this expression is known as the dissociation constant of the acid. ठीक है, तो बस उसी का नाम है दूसरा. So it is an application of Kc. So if you have propanoic acid will ionize, it will produce these two ions, and it will have an acid dissociation constant, which is going to be this ion into this ion divided by the reactant concentration, which is this. ठीक है? Is this clear? What is Kc? Sorry, what is K? Is this clear?
Yes, sir.
So weak acid, it ionizes, right? One other thing I discussed was that if propanoic acid ionizes, so these two ions will be produced in exactly the same ratio. कि अगर इसके 5 molecules बनते हैं, 5 ions बनते हैं, this will also be 5 ions, right? So both of them will have exactly the same concentration, right? क्योंकि it's 1:1. So if 10 molecules of propanoic acid ionize, they will produce 10 H+1 and 10 propanoate ions. Since both of these ions have exactly the same concentration, if I go to the general equation, H+1 and X-1 have exactly the same concentration. So what I can do is I can rewrite this expression, and I can, instead of writing H+1 into X-1, I can just call it H+1 squared, क्योंकि दोनों की concentration exactly same है. So why write X-1? Just write H+1 twice, right? So, I mean, the same expression turns into this expression. Is this part clear? Rizwani, clear? So, is this clear to you?
Sir?
Yes.
Sir, X-1 की वजह आपने H plus को square कर दिया?
हाँ, क्योंकि दोनों की concentration will be exactly the same, right?
Yes.
So, but why write X-1 when it has the same value as H+1? So instead, just call it H+1 squared, right? So the point is, okay, every acid will have a dissociation constant, and that's going to be this thing. It's going to be H+1 squared divided by the acid concentration. मतलब यहाँ पे ना, this ion into this ion, right? So this becomes H+1 squared divided by the acid concentration. When the K is large, that means ज़्यादा products हैं. So that means it's ionizing more. So the acid ionizes more, and it's a strong acid. ठीक है, so this thing over here indicates जो K large है ना. अच्छा, K large indicates that it's going to be a strong acid. मैं इसको सही करूँ. अच्छा, K large indicates that it will be a strong acid because it's ionizing more. There are more products, and K small means that it's going to be a weak acid. And remember, we're talking about it in relative terms. K जो value है ना, that applies to weak acids. ठीक है, so but weak acids में there will be some that will be stronger, and there will be some that will be weaker. So that's the whole expression. So we'll start doing some past paper questions related to this. Questions will be very simple. You just need to know the formula. Okay, what's going to happen. So let's open the worksheet. Okay, just remember the expression. अच्छा, कहाँ पे worksheet? Just one second.
Sir? Sir, इसके अंदर आपने लिखा कि BH या BOH इसके अंदर minus log लगा है, तो ये कोई formula है इसके अंदर?
मैं बताता हूँ, एक second. अच्छा वो माइनस लॉग वो मैं थोड़ा सा एक्सप्लेन कर देता हूँ कि अच्छा एक ये के एसिड एसोसिएशन कांस्टेंट एंड द अदर थिंग इज कहाँ गया हमारा वो के डब्ल्यू था राइट के डब्ल्यू तो क्लियर था ना कि के डब्ल्यू is for it's known as the water constant. It's Kc for water ionizing. It's H plus 1 concentration into OH minus 1 concentration divided by the water concentration. Like in water excess mein, so you don't take it in the expression. You anything that's in excess, it's not written in the expression. Okay. Or I did explain what is the value of Kw. Kw has a value of 1 times 10 power minus 14. Normal water जो है एसिडिक होगा तो H% ज्यादा होगा OH ions कम होगा but the product will still come out to be 1 times 10 power minus 14. So this is your Kw expression. Why did I take the negative of log? अच्छा negative of log है ठीक है यहाँ पे put a negative sign. अच्छा why do you take log? Log is good for making graphs. That's it. कि log में ना आप values को 10 की powers में express करते हो. So if you have this number 100,000, if you take log of this is 10 power 5, so you get 5. This is 10 power 1. You see that this is 10 power minus 5. तो log के अंदर numbers जो आते हैं ना they're very good for making graphs. तो जब आप pH measure कर रहे होते हैं ना you're constantly tracking the concentration of H plus 1 and OH minus 1 in water because every reaction is happening in water. So you want to track like how many H plus 1 does it have and how many OH minus 1 does it have. So that's why we take the negative log of it. क्योंकि log के अंदर it becomes very easy to make graphs. ठीक है? कि concentration could be very low, it could be very high as well. तो अगर log का थोड़ा सा idea ना तो what will happen is that when two things are getting multiplied in log, the things are getting added because you got a minus sign. So it's minus log of H plus 1 and minus log of OH minus 1. और इसका log लोगे तो ये 10 की power में express करता है, that's 14. Because you got a minus sign, so it's going to become plus 14. तो pH जो होता है ना तो pH is the negative log of the concentration of H plus 1 ions. Why do you want to take log? Because H plus 1 concentration बहुत कम भी हो सकती है 0.00 let's say 10 power minus 5 mole per dm cube भी हो सकती है बहुत ज्यादा भी हो सकती है like 1.5 mole per dm cube. So it's very hard to actually plot these values on the same piece of graph paper. So what you do instead is you take the log of it. Log के अंदर you'll get nice whole numbers. तो इसलिए ना वो graph बड़े अच्छा बनेगा उससे. रिजवान समझ आइए बात कि why are we taking log?
Yes.
And the reason why we're taking negative log is concentration is usually in decimals, like 0.15 mole per dm cube, 1.5 mole per dm cube, 0.015 mole per dm cube. So when numbers are in decimal, तो 10 की powers क्या होंगी? वो negative होंगी ना? So instead of making a graph of negative values, we just multiply it by minus so that we don't have to make a graph that has negative values in it. Is that clear?
Yes.
क्योंकि concentration कभी भी ये 100,000 तो होगी नहीं मतलब ये हो सकती है concentration 0.001 right concentration is usually not greater than 10 or 15 mole per dm cube right so you're never going to get a positive number when you take log so इसलिए वो you multiply everything by negative so that you don't get negative numbers. अच्छा but anyways ये clear हो जाएगा question करते हैं ठीक है we'll just remember we did two things we did Ka and we did Kw as well. अच्छा for example this question ठीक है this first one और एक सेकंड में देख लेंगे कौन सा वाला है हाँ अच्छा so for example this one is kind of slightly tricky. What does the ये organic का part है कि like how do you compare the acidity that's all organics so we'll study that in organic but this one the question is the numerical value for K is given for this is methanoic acid and this is I don't know some acid उसने नाम दिया it's pyruvic acid. So what is K? First one for methanoic acid I'm going to write the expression methanoic acid if you know how it ionizes that's a normal carboxylic acid. So it's going to be HCOH and it will ionize and it will produce what HCOO minus 1 ions and it's going to release 1 H plus 1 ions, right? Exactly what equation. It's what is that equation? HX ionizes, produces X minus 1 and H plus 1 ions, right? So, sorry. Achha, so it's exactly the same expression. So what is the dissociation constant of Ka for this one? It's product concentration HCO minus 1 into H plus 1, and the whole thing gets divided by, so the whole thing gets divided by HCOOH concentration, right? And it has a value of 1.78 times 10 power minus 4. The other one is pyruvic acid. That's also a carboxylic acid, although it's got a ketone part in it as well. So this one is CH3CO, and you have COOH, and it's going to ionize, and it's going to produce CH3COCOO minus 1 plus H plus 1. Anyway, so what is the K expression for this? The K expression for this one is going to be, or इसको let's say K1 कह देते हैं, and this is my K2. Now this is a separate acid, so product concentration CH3CO COO minus 1 concentration into H plus 1 concentration, and the whole thing gets divided by CH3COCOOH key concentration, right? Is this clear? The two expressions, you clear?
Yes, sir.
So you got one, so and you have the values for both, right? So you got both expressions. Now the question is slightly tricky, because it's slightly you just have to think a little bit. He's asking to use these K values and find the K equilibrium. I mean, this is Kc. He's saying, okay, find the Kc for this reaction, the equilibrium constant, K equilibrium. So what is your equilibrium constant for this one? It's product concentration, so it's HCOOH concentration. The other thing is CH3COCO2 minus 1 concentration. That's your product. And then you're going to have your reactants. So I'm going to add my reactant concentration. So it's HCOO minus 1 concentration, and the other one is CH3COCOOH concentration. He's saying कि इन दोनों को find out करके use करके find the value of K equilibrium. Now, if you look at this carefully, how can you find K equilibrium based on the values that are given over here? K, if you multiply the two expressions, I mean, if you look at it carefully, this K equilibrium expression is basically K1 divided by Ka2. I mean, look at the two expressions. You got K1 over here, right? So if I take K1 and I divide it by K2, well, इसके नीचे कर लेता हूँ, K1 divided by, so let me do that, K1 divided by K2. So this is HCO minus 1 concentration into H plus 1 concentration, and the whole thing gets divided by HCO COO H concentration. So if I divide the two expressions, the H plus 1 will get cancelled out, right? And it's going to be CH3CO minus 1 multiplied by HCO. I mean, when you divide something, it gets multiplied by the inverse, right? So CH3CO minus 1 would get multiplied by HCOH, which gives you the numerator, and the bottom part will be CH3 COCOH, and it will be multiplied by HCO minus 1. Like if you do the math, K1 divided by K2, you're going to get this, you're going to get exactly this expression. So is this question clear, this one?
Yes.
So Baki, you just have to find the value. To tell me what the value is. It's because he's asking for the value. So K1 is 4.07 times 10 power minus 3. बाकी को clear है? Anna, Alicia, is this clear? Shahan, Naseeb, सारों को clear है? और नीचे जो है ना, that's 1.78 times 10 power minus 4. तो इसका मुझे आंसर बता दो क्या? What do you get for this? क्या है? क्योंकि अगला पार्ट फिर बताना है कि उसके हिसाब से बताना है. We have to tell that 22.865, right? So that's kind of a big number. What does that mean? K equilibrium, does it favor the products or does it favor the reactants? अगर बड़ा number आता है equilibrium constant का, so that would mean that it will favor the हाँ.
सर इसके अंदर ये जो 4.0 1.78 है, सर ये ऊपर नहीं आना चाहिए इसके हिसाब से?
किसके हिसाब से?
जो आपने कैंसलिंग की है, इक्वेशन 1 को इक्वेशन 2 से डिवाइड किया.
नहीं, उसके एक्सप्रेशन को जो डिवाइड किया है कि K1 divided by K2, right?
या सर.
तो बस K1 divided by K2, तो you get this expression. K1 is this one, नीचे वाला 4. ये था K1 4.07 times 10 power minus 3 और ये K2 है, that's 1.78 times 10 power minus 4.
ओके सर.
अच्छा, बड़ा नंबर आया. बड़ा नंबर का मतलब है, it favors when you have a large value, you have to explain this as well. When you have large value for product concentration divided by reactant concentration, that means products are favored, right? Is that clear?
सर.
हाँ.
सर वैसे हमें आइडिया कैसे होगा कि लार्जर वैल्यू राइट को फेवर करती होगा, ये स्मॉलर वैल्यू लेफ्ट को फेवर करती होगी?
नहीं, products over reactants अगर 1 से बड़ा आ रहा है, तो that means you have more products and you have less reactants, right?
ओके सर.
और अगर 1 से छोटी आ रही है, that means you've got less products and more reactants, right?
और सर ये मिडिल में कब लाई करती होगी? लाइक
1 पे ना, 1 कब होगा? जब product
Okay.
concentration,
Okay.
reactant concentration is exactly the same.
ओके सर.
अच्छा, next one कि वो कह रहे हैं कि ethane dioic acid has two dissociation constants K1 and K2 whose pK values are. Achha, let me explain what pK values are. K, we did talk about K, right? Achha, we talked about K and K was कहाँ किया था? This is ठीक है. So pK is simply P मैंने explain किया था. What is P? pH minus log. ठीक है. When you take minus log, it becomes P. तो pK अगर लिखा हुआ ना, if he's talking about pK, तो pK is the negative log of K. ठीक है. So whenever you talk about K, A, or whenever they say P, that means minus log. You're taking the minus log. So that's what pKa is. Or why did we take negative log? क्योंकि K की जो values होती है ना, they're very hard to actually plot on a graph. ठीक है. This is how I did show K values for weak acids. Every weak acid has a certain K value. So if you have a look at the K values, they're kind of really small. 10 power minus 4, 10 power minus 12, 10 power minus 2. So अगर किसी ने कह दिया ना कि इसको plot करो graph पे, you can't really plot them on a piece of graph paper because they're too small. I mean, it would be very hard to actually choose a scale. Okay, if somebody is asking you to plot all these K values on a single piece of graph paper, so what you instead do is you take the log of all these values and you take the negative log. क्योंकि अगर log लोगे ना, you'll get a negative answer. 10 की powers में, it's going to be a negative number. So instead, you don't get a negative number, you take negative log. So the point is, you don't really deal with K, अब ये देखो ना, pK value, same thing. That's nice whole numbers. It's easy to plot on a piece of graph paper. तो बल्कि यहाँ पे अगर देखोगे ना,
सर
हाँ जी,
सर डू वी लाइक हम लोग नॉर्मली कभी पॉजिटिव लॉग्स के साथ डील नहीं करते ना,
नहीं
जस्ट क्वेश्चन और टेम्पलेट।
पॉजिटिव लॉग कर सकते हो, लेकिन यूजली इसमें क्योंकि हमारी वैल्यूज जो है ना, दैट्स दे ऑलवेज वेरी स्मॉल। तो ये 1.8 times 10 power minus 5 का, if you take the negative, if you take the log of this, मतलब what do you get? It's मैं इसका लेके देखो, 1.8 का log लो ना, 10 power minus 5, just 1 second. 1.8 exponent minus 5, right? अच्छा, if you take the log of this, क्या था 1.8? Just 1 second. 1.8 exponent minus 5. अच्छा, I get minus 4.7, ठीक है? So because I don't want a negative value on my graph, I multiply it by minus, ताकि वो प्लस हो जाए, ठीक है? वरना वो कर सकते हो, बस वो प्रॉब्लम होगा, all your values will be negative. So you just don't want negative values on a graph, ठीक है?
ओके ओके।
अच्छा, तो ये क्लियर है कि so instead of actually dealing with pK, किसी को ये समझाना ना 4.7 times 10 power minus 11, pK is a lot easier to actually even tell someone कि भाई इसका pK जो है ना वो 10.3 है. That's a nice whole number. So that's why we don't actually normally we don't actually deal with K. We actually talk about pK. इसी तरह H+1 की ना we don't normally deal in concentrations. We deal in pH. क्योंकि नेगेटिव लॉग में ना pH1 है, pH2 है, that's a lot easier instead of telling them that it's
सर
हाँ जी,
सर ये pKa क्या रिप्रेजेंट कर रहा
K को।
है?
और ये याद रखना कि when you take negative log, the things are opposite. Like when K is large, that means pK will actually be small. ठीक है? And similarly, when K is small, pK would actually come out to be large. और ये मैं explain भी कर देता हूँ calculator पे. You can have a look at your calculator. Like when pK is really small, 10 power minus 14, right? So 10 की powers क्या होंगी? वो बड़ी आ गई ना. That's, I mean, the number is actually small, but when you take the log, when you express it in the powers of 10, you get a big number. Similarly, when Ka is large, this is 10 power minus 2, that's kind of large. The power क्या है? That's 2, right? So you get a small number. Is that clear? कि
यस सर।
क्योंकि वो पावर्स में है ना, तो जितनी वो छोटी वैल्यू होगी ना, 10 power minus 11, तो 10 की powers पे you're going to get something close to 11 over here, right? So you'll get a big number, and the bigger the number is, 10 power minus 2, that's a big number. Relatively, that's a big number out of all of these values. इसका जब log लोगे ना, so you'll get something that will be very close to 2. क्योंकि 10 की power minus 2 है, so you'll get something that's very close to 2, and then you'll get a small number. तो वो उल्टा हो रहा है. pH में भी उल्टा होता है कि H+1 की concentration जितनी कम होती है ना, यानी अगर वो 1 times 10 power minus 13 है ना H+1 की concentration, तो log के अंदर ना you'll get 13, you'll get a big number. H+1 की concentration जितनी ज्यादा होगी, for example 10 power minus 1 होगी, log के अंदर you'll get 1, so you'll get a smaller number. तो जिस तरह pH में everything is the opposite, यहाँ पे भी pK के अंदर everything would kind of be opposite. Okay, pK small means that the K is actually large, and pK large would mean that K is actually small. तो ये बाकी सारों को clear है? आमना, ऋषभ, एना, वसीम, शान clear है? उमर clear है? So just remember, instead of dealing with K values, we actually like to deal with pK values, and instead of dealing with H+1 concentration, we want to deal with pH values. Okay? We want the negative log values because they're nice whole numbers. That's the only reason why we want them. अच्छा, वो कह रहे कि अच्छा, this is something that I had discussed. वो कह रहे कि दो equations देखो. I told you that when you have a diprotic acid, every weak acid will ionize it this way. It's going to be HX, and that will ionize, and it will produce two ions. One is H+1, and then there's some random negative ion, whatever that is. Now we've got a diprotic acid. That means it's got two carboxylic acids. So it's got two carboxylic acids. So it can release this H+1, it can also release this H+1. I told you that when an acid has two H+1, it's not going to release those two H+1 in one go. Okay, this is not what's going to happen, that the two H+1 will be released and you'll have CO -1 and COO -1. This is not what's going to happen. What will happen instead is पहले एक H+1, one of the H+1 will get released. So one of the H+1 will remain, two steps mein hoga, and it will release one H+1. Then once that happens, then this ion over here, jo bacha hai na ion, that will release the other H+1 ion as well. And you'll get COO -1, COO -1, and another H+1. So in both cases, you get kind of the same expression. So I told you that when you have a diprotic acid, both H+1 will not get released at the same time. I told you that when a phosphoric acid example diya tha. Okay, like when you have phosphoric acid, somewhere over here, I explained that don't think of phosphoric acid as one acid. It's not going to release the H+1 ions in one go. Instead, what will happen is if pehle ek H+1 release hoga, it's going to form H2PO4 -1 ions. Then that H2PO4 -1 is going to behave as a different acid, and it will release the other H+1, and it will form HPO4 -2. Then this HPO4 -2 is going to release another H+1, and you will end up with PO4 -3. ठीक है, तो तीनों इकट्ठे, they won't get released all at the same time. And all three will behave as three separate acids. So phosphoric acid is not actually one acid, it's actually three acids. The first ionization happens for phosphoric acid. The next one, the H+1 gets released from this ion. The third one, the H+1 gets released from this ion. Or kya hota tha? Why the acids would become weaker as the ionization proceeds? Because when the ion becomes negatively charged, it's a lot harder to actually let go of an H+1 because you're attracting the H+1 more strongly. So neutral ke liye na H+1 lose karna, the first dissociation is easy. The second one is a bit harder. The third one is even harder because it's now a -2 ion. वो तो उल्टा H+1 को वापस attract करेगा, ठीक है? So the same applies to this acid because it's a diprotic acid. It's a double carboxylic acid. Dioic acid है. So the first ionization would be easy. तो उसकी pK value जो है ना वो small है. ठीक है? What does small mean? Small means के the actual Ka value would be large. That means it's going to ionize more. The first one will ionize more. For the second one, once the first has ionized, the next H+1 will be a lot harder to be released because it's already a negative ion now. And instead of losing an H+1, it will instead be attracting H+1. So it would be very hard for it to lose an H+1 once it's becoming a negative ion. So uski jo pK value hai na, that's coming out to be large. That means its K value would actually be small. Is this clear?
Yes, sir.
So ye yaad rakhna कि diprotic, triprotic acids, don't think of them as one acid. Think of them as multiple species that are constantly losing H+1 ions. So it's basically this acid.
Sir?
हाँ जी.
Sir, और ये नीचे वाले में तो inverse relation होगा ना? I guess.
क्या?
ये जो state the mathematical relationship वाला.
वो कह रहे कि तो pK क्या होता है? It's minus log of negative log of K, right? That's it.
Yes.
तो उससे बस ये मांगा हुआ है. अच्छा, anyways, organic, let's skip organic to K questions. अच्छा, this one. So over here, he's saying the ionic product for D2O. D2O is a isotope of water. I mean, deuterium is a isotope of hydrogen. Okay. So it's going to behave in exactly the same way. Think of D as H. It's just an isotope, right? So what would happen when water would ionize? It will ionize and it will produce H+1 and OH ions, right? Now, if you have heavy water like D2O, and that will ionize in exactly the same way. It will produce D+1 ions and OD-1 ions. Okay? Is this clear? Okay, deuterium is just an isotope of hydrogen, where the hydrogen has one more neutron, right? So anyways, this one, he's saying, right, the Kw expression. What is the Kw expression? It's going to be product concentration. So it's going to be D+1 concentration divided by OD-1 concentration, right? Divided by the reactant, which is water in this case, D2O. Lekin water jo hai na, that's an excess. So you don't, remember in aqueous solutions, you don't write water in the expression because it's in a large excess. Is that clear?
So, तो हम as it is लिखेंगे कि D plus into OD minus. So यही हमारा expression होगा. Okay.
हाँ यही होगा. So water के case में it was H+1 into OH-1, right? Water constant, right? So the only thing that has changed is that he's using a different isotope of water. Is this clear? ये part clear है सारों को?
Yes.
So वो calculate the pH of pure neutral D2O. अब उससे ना, he gave you the value for Kw. First thing, these two ions will be produced in exactly the same concentration. So let's do this as the last question. If X mole per dm cube of this is produced, then X mole per dm cube of OD-1 ions will also be produced. Remember, they will be produced, or water will ionize in exactly the same ratio, right? So अगर ये X mole per dm cube होगा, तो this one would also be X mole per dm cube, right? So Kw will have D+1 concentration multiplied by OD-1 concentration. Is that clear? मैंने assume कर लिया कि the concentration of D+1 and OD-1 is X. Both of them will have exactly the same expression. They've given me the Kw value for this thing. That's 1.35 times 10 power minus 15, right? I say using this, what I get is 1.35 times 10 power minus 15, and I would have to, agar wo square hatana, I would have to under root this. So what do I get when I under root this? It's इसको जल्दी से कर लें कि 1.35 e minus 5 minus 15, sorry, and you would have to under root this. Under root 1.35 e minus 15. So I'm getting minus. Can somebody tell me what the value is? So I'm getting, decimals, I'm getting 3.67 times 10 power minus 8 mole per dm cube. तो इसका मतलब है मेरा जो H+1 है ना, that's coming out to be 3.67 times 10 power minus 8 mole per dm cube. And remember, that is my H+1. I mean, it's just an isotope of H, but that is the H+1. The next thing is, all you have to do is you have to calculate pH. What is pH? pH is the negative log of the concentration of H+1 ions. So it's going to be negative log of 3.67 times 10 power minus 8. So pH आ जाएगा. So just take, so all you have to do is take the negative log of this thing. So जो भी log 3.67 exponent -8, and I think that gives me 7.4. ठीक है, that is my pH. ये क्वेश्चन क्लियर है? चलो ये कल हम इस तरह के और क्वेश्चंस कर लेंगे, ठीक है? But is this clear that this is D2O is just H2O? It's just the same thing. It's just a different isotope of H. जो इसकी concentration होगी वो इसकी होगी.
सर
हाँ जी.
सर ये चैप्टर अभी खत्म हो गया?
नहीं, अभी है काफी चीजें इसमें.
Okay.
अभी हमने सिर्फ 2 चीजें की हैं, KW और KA. That's it.
ओके सर, एक क्वेश्चन है सर। मैं कह रहा था कि अगर आप लेट्स सपोज ये टॉपिक खत्म करें तो फिर आप केमिकल एनर्जेटिक स्टार्ट कर सकते हैं इसके बाद।
अच्छा, एक से वो मैं तुम्हारे से डिस्कस करता हूँ, ठीक है?
ओके
चले, ओके, टेक केयर, हाफिज. कल इसको ना डिस्कस करते हैं आप, या